Murray, just going to refresh you on a few of the Desmos tools for your final project. If you like, just a few of the things you can do, which you may have forgotten about. Remember, you can over here change the settings of your graph. So, for example, if you click on this wrench, you can make it a little bolder, projector mode. You could make the background black with the reverse contrast. Sometimes that looks cool. You can take the grid away if you like, or put it back. I think it's good to draw it with the grid, and maybe at the end, maybe you take it away, and so all you see is your drawing. But totally up to you. You can also set your window. Remember, if you besides just zooming out or zooming in, if you wanna, you want the x-axis to be, from -1 to 20, to give yourself some room to work with, and you want your y-axis to be from -1 to 20, or whatever you want. But you have that there, and anytime you want to go back to the home, you can always do that, and it'll go back to the normal here. You put your equations in here, and so for example, suppose you just want to put a point. Maybe you want to make a face or something, and you want to put an eyeball and make a point to do that. So you could do say, I don't know, 10 comma 12, and there it is. It's a point there. And remember, next to whatever equation or point or thing you put in here, when you hold this down, you click on this and hold it down, you can change the color of it, you can change the style of it. So if you want it to be red, or if you want it to be an open circle, or if you want it to be an X, totally up to you. So there we go. Maybe I'll make a second eyeball at we're just doing a little demo here. How about 12, 12? Just a little space. I'll make the same color. And also you can shut it off if you don't want to see it, but if you don't want to erase the equation, whatever you've drawn, just click on that. Okay. And reminder that, so suppose I want to maybe give it some eyebrows. Here's something you can do. Now, if I wanted to give it some eyebrows to be like a line, for example, y equals mx plus b, slope-intercept form. So you can do y equals, if I wanted it to be maybe this right eyebrow that goes right there over that right eye, you could estimate that's a positive slope. Maybe if you want it to be going right through that point with a slope of 2, you could say that's going to be 2x, and then adjust the y-intercept until you get it to right where you want it to be. But also remember, besides slope-intercept form, you have point-slope form. So for example, if you wanted to go through that point 12 comma 12 with a slope of 2, you could type the equation in that way, which is what's great about Desmos. You could put y minus 12 equals 2 times x minus 12. And then it'll go right through that point. And if you want it to maybe be just a little bit above that point, you can change the y coordinate a little bit, and it'll still be, won't go right through the middle of it. But here's another thing you may have forgotten. We did this a lot with marble slides. If I don't want to see the full line, like if I only, like an eyebrow, I only want to see a little bit, remember you can restrict the domain of it. After your equation, you put the fancy brackets here, and you can do things like, I only want this graph for x values greater than 12, and so x is 12, and that's where it'll start, and it'll only graph it for x values to the right of that. If you want it to be, double-sided restriction, like you only want a little segment here, suppose I only want it to exist between 12 and 13, well, then you can say, using the compound format here, x between 12 and 13, greater than 12 but less than 13, and you can play around with that as you see fit. You can make that, if that's too long for you, you can make it 12.5, and if you want this one to go a little bit further to the left, you could do 11.8, but whatever, there you go. I'm going to leave that eyebrow there, and I'm going to leave it purple. Cool. But remember, with graphs other than points, you can, besides changing the color, you can change it to be dashed, which would look cooler, I guess, if the graph was longer. You can do things like, instead of an equals, you can put inequalities, and that shades it. If you put less than, it's going to shade underneath it. If you put greater than, it's going to shade above it. Might not be what you're going for, but just to remind you of some of the things you can do. If I want to give it a smiley face, maybe I want to put a smiley face right there, or a frown, whatever. That would be great for a parabola, right? And a parabola, besides, remember their standard form, y equals x squared, ax squared plus bx plus c. But vertex form would be great if you want to put it right there and you want the vertex to be at a very specific location. Like, what is this point right here? It looks like it is 11, 8. So if I want 11, 8, I can do x minus 11 squared plus 8, right? That's the vertex form. And again, I would probably want to restrict the domain, so I'll use the fancy little brackets, and in between, say I only want it to exist between 10 and 12. 10 less than x less than 12. There you go. And suppose it doesn't look quite right. Suppose you want to make him look a little angrier. You could have it opening down. It could be a sad face, right? That's what a negative out in front of that quantity does. If you wanted to be a wider smile or a wider frown, remember you can do things like changing the a value in front to be a 0.25. That makes a wider parabola, what we call a vertical compression. If you change it to be a 2 out in front, something bigger than 1, then you get a skinnier parabola, what we call a vertical stretch. It's like changing the slope of the parabola, making it steeper. So all kinds of little things, and I just encourage you to just play around. I'm only trying to remind you of a few things you can do. Another equation, another graph we've learned about this year, which must be included in your final, is the exponential graphs. And exponential graphs are like y equals 2 to the x, things like that. That's that exponential growth curve. And exponential growth looks like that. If you make the base something less than 1, like 1/2 or 0.5 or any decimal less than 1, you get the exponential decay curve. It's just going the other way. If you want to move it around, it's very much like with the parabola. You can put parentheses around the x part, and if you put minus 10, it's going to move 10 units to the right. It affects the x value. If you want it to move up, just like I put plus 8 on the end of my parabola, I can put plus 8 on the end of that, or plus 6 if I want it to be, I don't know what I'm going for here, but you want to restrict it, and you put some fancy brackets at the end. So all kinds of stuff you can do here. I don't know what that would be. But hey, you can play around, just trying to remind you of a few things you can do. And then I said you have to have a couple special functions involved in your graph. And special functions are maybe some things we haven't really looked at this year. And for some ideas, if you open the keypad here, the calculator part where there's the exponent buttons and inequalities, there's a few things. One is the square root function. We talked about simplifying square roots this year, but we didn't really look at its graph. But if you did y equals the square root of x, look at what it looks like. It's like half of a sideways parabola. And just like all these other graphs, it doesn't matter what the function is. If you want to move a particular graph around, suppose I want to move that 10 units to the right, I'll put minus 10 on the inside with the x. If I want to move it up, so I want to move it up like 10 units, I'll put plus 10 on the end. If I want to restrict its domain to its x values, I'll put some brackets at the end. So there's a square root function. Y equals, if you see some other things, here's an absolute value. Absolute value of x. Take a look at this graph. It's a v. If you want to move that v around, it's kind of like a parabola, except it's not curved. If you want to move its vertex 10 units to the right, I put minus 10 on the inside. That shifts it 10 units to the right. If you want to move it up 5 or up 10, whatever you want to do, up 8 units, there you go. There's that. If you want to do some other functions, here's one that you might like. This is a graph of a circle. You'll do some more with this in the future, geometry and algebra 2. But the equation of a circle, x squared plus y squared equals 10. And it doesn't look perfectly circular here because I changed the scale, so it's kind of stretched more in one direction than the other. But you know, you can get cool things, like you can shade the inside by making that a less than. And again, if I want to move that to the right or to the left, for example, if I want to move it to the right, instead of just x, I'm going to put x minus 7 squared. And see, it moved 7 units to the right, but it didn't move up or down. If I want to move it up or down, I'll make a y set of parentheses and put y minus 12. And that will move it 12 units up. If I want to play around with that and move it more to the right, you know, very simple. Kind of cool stuff to just play around with here. And that's the main thing. If you want to make it a bigger circle, you change this number to a bigger number. And so there you go. I mean, you can do all kinds of stuff. You can change that. I encourage you to play around. Some other things you could do are just make a polynomial, but with bigger exponents than 2. So you could put x to the third minus 2x squared plus 14x. I mean, you can do anything. And you see you'll get some really funky curvature there, and you could make this even bigger. You can make it x to the fifth and whatever exponents you want. There's also something here in math that you'll learn about called trigonometry. And in these functions here that are built in, you've got sine and cosine. That's what those buttons are that have been on your calculator. You'll use them next year. But again, you could put sine, y equals sine of x, and look at the graph you get. And you can play around with any of the others. I'm just trying to give you some ideas of things you can do. Y equals sine of x, you get this like sound wave kind of graph. So a lot of cool stuff you could do with that. You know, you could minimize, only take a portion of it and move it up. Again, if you want to move it to the right and up, although when you move it to the right, it doesn't really look that different because it's just a continuous thing. But if you want to move it up, I'll put plus 8 on the end. So all kinds of different stuff you do there. I encourage you to just play around, be a little creative, but I'm not expecting you to have perfect things. But some of you are very creative, so just to give you some inspiration here, these are just some things that other people have done that I've seen. Very cool there. Look at that. That's not a particular like thing that someone's trying to draw, but just a cool looking design. Very cool, right? Look at that. That's definitely made with parabolas and circles and maybe some exponential growths and some lines and things. Just beautiful. Look at that. It looks like a 3D donut there, but I think it's all just a bunch of sine and cosine graphs. Very cool, right? So we've looked at a bunch of things there. This person wrote out the word algebra and had a parabola and think, hey, very cool. Ooh, look at that. But look at all the equations that person used to make it. So, I mean, that's going a little above and beyond, but some of you might really get into it and see what you can do and kind of push yourself on it. So, hey, the sky's the limit. I'm just trying to give you some ideas of how you can do things and how you can limit some things. You got any questions? You just ask. Have a little fun with it. That's the important thing. All right, kids, take it easy.